Hello and welcome to the walking talking topic on bounds and estimation, question number 3 with me, Mr. Barton. Right, we've got another tough one here, 6 marks available and it's all kicking off in this question. We've got Lois and she's decided that she's going to run 7 kilometres and she's done it in 25 minutes and 23 seconds. I mean, that's an awkward time just to begin with, but here comes the twist. The distance was measured correct to the nearest 10 metres. Not even in kilometres, and the time was measured correct to the nearest second. Calculate the greatest possible average speed and give your answer in metres per second. Right, loads to do here, but 6 marks are awaiting us if we can get it right. Now, we'll worry about this greatest speed in a second. The first thing is, let's get our units sorted. If the answer's got to be in metres per second, let's get a distance in metres and let's get a time in seconds. So distance was 7 kilometres. Now, what's that in metres? Well, 1 kilometre is 1,000 metres, so 7 kilometres must be 7,000 metres. Okay? Let's get a time. Let's get this in seconds. Now, she does 25 minutes and 23 seconds. Well, the 23 seconds is all right, but it's the 25 minutes that's a problem. So we're going to have to do 25 minutes, and in each minute there are 60 seconds, and we're going to have to add on to our answer 23 seconds. Well, here let's turn to the trusty calculator. 25 minutes, and in each minute there are 60 seconds, and we'll get our answer to that, and then we'll add on our 23 seconds left over, and that tells me that she actually did it in 1,523 seconds. Okay, now we're going to get to the bounds bit of the question. Because the distance was measured correct to the nearest 10 metres, so it wasn't in fact 7,000, it could have been anywhere between something upper bound and a lower bound. So I like to do a little diagram here to do this. And if it's measured to the nearest 10 metres, that means there's got to be a 10 metre gap between the upper and lower. And then it's dead easy. So the upper bound must be 7,005, because any more than that it's going to round up to 7,010. And the lower bound must be 5 less than 7,000, which I think is 6,995, because any lower than that and it's going to go down to 6,990. So this is my upper bound, and this is my lower bound. Now, what about the time? The time is measured correct to the nearest second. So it's 1,523 seconds. And again, I'm going to need an upper bound for that and a lower bound. And that's got a distance of 1 second. So it's going to be 1,523.5. Any more than that, we're going to go up to 1,524. And it's got to be 1,522.5, I think, for my lower bound. So, things aren't looking too bad. What is her greatest possible average speed? Well, we've got to know something about speed first. Speed is equal to the distance travelled divided by the time taken. Now, how are we going to make that speed as big as possible? How are we going to make Lois seem really impressive and really fast? Well, we want her to have covered a big amount of distance to make her impressive. So we want the upper bound of distance, and I'll show you why this is true in a second, 7,005, divided by, well, we want to have done it in the quickest amount of time, because remember, we're trying to make this speed fast. So it's your upper bound of your distance. She's travelled as far as she possibly can, and she's done it in the fastest time possible, 1,522.5, which has got to be the lower bound. And if we bang that into the calculator, so we get, she's done 7,005 divided by 1,522.5, press equals. Now the calculator gives us a nasty value there, so let's SD that, and we end up with 4.6009 ... meters per second. Now, firstly, just check that that actually makes sense in the real world. Somebody's running, can they cover about 4 meters per second? Yeah, that sounds fairly reasonable to me. But second, let's check that there's no way we can get that any bigger, that speed any faster. Well, all we can do is play around with these numbers. And if you just say, for example, did the upper bound, because this is what a lot of people do, to make something as big as possible, they do the upper bound divided by the upper bound. Seems logical. But that only works when you're multiplying, and I'll show you why. If we put that in 7,005 divided by 1,523.5 and press equals, we end up with an average speed that is slower than what we had before. So it can't be that. It cannot be that. So let's make sure we cross that out. That's got to be our answer. So to make something as big as possible when you're doing a division, it's the biggest something can be divided by the smallest it can be, and then you to go.